Dear students, last day I taught you about that Coulomb's law and the difference between the electrostatic force and the gravitational force. Now today I will teach you about that the charging by induction method or charging by conduction method. Now first we discuss about charging by induction. In the induction method, suppose that we have a neutral body. And just this neutral body come in contact with a glass rod or positive rod. This positive rod just come in contact with this neutral body. This is neutral body, number of proton equal to number of electrons. This is positive charge body, positive charging rod, positive charge rod. Not completely touch to this neutral body, only just come in contact with each other. Then the positive charge, first condition. In the second condition, if we just in contact with this neutral body, the positive charges is shifted to the other side and negative charges is shifted to the this side. But the condition is this: if we just remove this glass rod, then this body repeat its previous condition. Again it is neutral body. In third condition, we just this positive charge connect to the earth. And now the positive charge shifted into the earth, and finally we have this is neutral body. Now we can also remove this positive charge body, positive charge rod or the earth connection. Then it will become negatively charged body. The neutral body will become negative charged body because it have excess of electrons. It shows the property of the negative charge of a body. And in second way, again if you have neutral body and just a ebony rod come in contact with negatively charged rod is come in contact with this neutral body, then the negative charge is shifted to the other side and the positive charge is shifted to the other side. First condition. In second condition, if we just remove this negative charge, this body repeat its previous condition. And in the third condition, the negative charge, this body we just connected to the earth. Then the negative charge is shifted to the earth and this body will become positive charge. Positive charge means positive charge body. Positive charge body means the deficiency of electrons. And after that we can remove easily the earth connection and the charging rod. And now we just tells about the charging by conduction method. Again we have a neutral charge body neutral charge body. Neutral charge body means the number of proton equal to number of electrons. And in this condition, we suppose that we have a strongly negatively charged rod just touch to the this neutral body. Then what will happen? The negative charge is, because it have strongly negatively charged in very congested area, negative charge is shifted to the here in the second condition. And it have, this body will be negatively charged. Number of electrons or number of negative charge is more or excess in the comparison of this, then this body will negatively charge body because excess of electrons. And suppose that when glass rod rub with silk, then glass rod have positively charged. A glass rod, positively glass rod, just come into the this neutral body, then the negative charge is just attracted to this positive side. And the body will have the excess of deficiency of electron or excess of the positive charge, and finally we have this will become positively charged body. Negatively charged body means the excess of electrons, positively charged body means the deficiency of the electron. This is clear charging by induction method or charging by conduction method. Now we discuss about that the charge distribution by three method, can say linear charge, volume charge and surface charge. How the charge is distributed in different types of the object. Now electrostatic force on a point charge due to continuous charge distribution. As we know that it is clear from this heading, this topic, electrostatic force, we calculate just electrostatic force on a point charge due to continuous charge of distribution. Suppose that we have a L length wire which is uniformly positively charged, placed in a plane or in a system. Its middle point is O, and distance from O to the positively, because it is clear from the topic, it is a point charge. A point charge is situated at a point P, which distance from the point O is R, and this is the small length area which is denoted by small length is dl. The whole length of this wire is L, which is uniformly positively charged. This, its distance from this is R dash, and the distance from this point P Q0 to dl, the small area element, small line element, small length element is R minus R dash. We just clear it. Q0 point charge, L length of wire, dl small length of wire, now how we can calculate the electrostatic force? If a uniform positively charged is distributed per unit length, if charge is distributed in per unit length in a system, then it is known as the linear charge density, which is denoted by lambda and Q upon L. Q is the uniformly charged distributed and L is the length of the wire. Then we can write this for the small length. This charge will write this dl. Then the value of dq, lambda dl. This is known as linear charge density, which is charge per unit length. Then now force on Q0 due to this small charge, force on Q0 due to dq, then the force also will be small, 1 upon 4 pi epsilon naught Q0 dq upon r minus r dash q, r minus r dash. dq value is here, as we know that with the help of the Coulomb's law, df equals to 1 upon 4 pi epsilon naught q0 lambda dl r minus r dash cube r minus r dash. q0 is to this lambda dl now for whole length of wire, the force on Q0, due to whole linear charge F equals to Q0 upon 4 pi epsilon naught L lambda r minus r dash dl. L is integration length, which is for whole linear charge. This is for linear charge distribution. And now just we tell about that the surface charge distribution. Surface charge distribution have, suppose that we have a surface of any object, this, it will be uniformly positive charge. It's a small surface area is ds, which is in a plane. Is a middle point is, center point is O, and a ds distance is r, same like as in the linear charge distribution. A point charge is situated at a point P, which is Q0 point charge, whose distance is r, and the distance between this Q0 and the this point P and the ds is r minus r dash. Then we can say, if we have this type of condition, the charge is distributed per unit area in this condition. If charge is uniformly distributed in this area per unit area, then we easily define that it is known as surface charge density In the previous case, linear charge density, it is denoted by sigma, that is denoted by lambda. The charge distributed, uniformly distributed per unit area is known as the surface charge density. For this, dq upon dA, dq is, value is this, because dq for a small charge and a small area. And now the force on q0 due to ds, force on q0 due to dq, df also equals to 1/4 plus epsilon naught on the basis of the Coulomb's law, q0 dq upon r minus r dash, r minus r dash, 1/4 epsilon naught, q0 dq value is sigma dA, r minus r dash का क्यूब, r minus r dash का whole. Then the q0 we can write this sigma dA equals to this is for small area, force on q0 due to dq for small charge, for force on q0 due to whole surface charge. Then F equals to q0 upon 4 pi epsilon naught A sigma r minus r dash, r minus r dash whole cube ds. Then finally we have q0 upon 4 pi epsilon naught A sigma r minus r dash, r minus r dash ds for surface charge distribution. And finally we have the volume charge distribution, volume charge distribution. In this condition we have a system this, and in this form is a cube, we have a cube, the small area, the small volume of this, the distance is uniformly positively charged. Again this is r dash and this is situated at a point P r, this is the distance is r minus r dash. dV. If this type of the condition, suppose we have a cuboid or a cube, then the charge is distributed is uniformly distributed. The charge is uniformly distributed in a given area, then in a given volume, then the charge per unit volume, charge distributed per unit volume is known as the volume charge density, which is denoted by sigma rho q upon v, and we write this q equals to rho v, and for small charge rho dv. And again the force on q0 due to this dq, force on q0 due to dq, then df equals to 1/4 pi epsilon naught q0 dq upon r minus r dash का whole cube r minus r dash. Then df equals to q0 upon 4 pi epsilon naught dq upon dq value is rho dv upon r minus r dash, r minus r dash. And we just write that for force on q0 due to whole volume charge or whole charge volume, then the force is this 1 upon q upon 4 pi epsilon naught v rho r minus r dash whole r minus r dash whole cube dv. The final condition is this: the linear charge density, surface charge density and the volume charge density. Now, importance of Coulomb law. What is the importance of the Coulomb law? It just to know about the nature of electrostatic force. To determine or to know about the nature of electrostatic force. It gives idea of vector form. It gives idea of vector form of Coulomb law. Number third, it is valid up to 10 to the power minus 10 meter to 10 to the power minus 15 meter. Now the fourth is, it obeys the Newton third law of motion. Now, limitation is this: electric charge must be at rest. The Coulomb's law only hold for this condition when electric charge is at rest. Number 2, charge must be point charge. It is only valid for must be a point charge. Number 3, the separation of the charges must be greater than the nucleus size. The separation of charge must be greater than the nucleus size. The nucleus size is 10 to the power minus 15 meter. It is enough for today. Now the next topic is the electric field or electric field lines, which will be start with next day, and today is for enough work.